Need to cut pipes or profiles over 500 millimeters? Don't buy before you watch this. Pros and cons of non-chuck pipe and profile cutting solution.
Laser pipe cutting machines were new. The main machine was mainly concentrated on two-chuck pipe cutters and plate tube integrated machine, because at that time people were mainly small and thin pipes. But the large inertia cutting action of the non-chuck did not occupy the thin and small pipes, so it was not widely used at that time. But in recent years, the increasing demand for processing large diameter pipes and the development of multi-chuck laser pipe cutting equipment, the advantages of non-chuck cutting have gradually emerged. In previous videos, about the non-chuck pipe cutting machine, I gave a vivid metaphor for it: a CT machine. The CT's process of detecting human tissue is essentially like using a camera to take pictures of you, taking a picture and moving forward, taking a picture and moving forward, until the tissue to be detected is photographed, until the tissue is scanned, is equivalent to the laser cutting head. Laser cutting head, the processed pipe, is like a patient lying on a moving bed. The existing chucking pipe cutting machine chooses to make the patient rotate wildly. The reason is simple, is that it is difficult to make the cutting head rotate. It's relatively large. Besides, the engineer can't stand it. The motor also says it can't handle it. The patient actually wants to say he can't stand it, but they can't control the situation. So everyone chose to let the guan side that doesn't speak rotate wildly. At this time, everyone found that patients' heights, weights, hunchback patients, it's hard to ensure. Always in the focus of the CT camera in the middle of the circle. So they invented a set of chuck fixtures. Force the fat and thin people fixed in the middle position, and then let the camera take pictures. At this time, everyone found that the cutting accuracy of pipes, in fact, depends on the clamping accuracy of the chuck. So people began to use various means to ensure the accuracy of repeated clamping. When the accuracy of this tool is improved to a high level, everyone found the pipes cut out still have poor accuracy. What's the reason? After searching, they found that the patient itself also had problems. Some pipes are hunched over, so the cutting accuracy at the end is good. But the middle part, the cutting accuracy begins to be abnormal. Some pipes even twisted like a twist. What should we do? Which makes software engineers to do the work. So we had two U's. We have to adopt many ways to adapt to these strange pipes, such as capacitance tracing, surface compensation, line laser scanning, and so on. Chucks, as the torture devices, are also very annoyed. You're always hunched over, right? I'll add a set of rollers to you. I'll force you to straighten. You like to twist and turn, don't you? I'll add another set of chuck to you to help you be well-behaved with everyone's efforts. We finally got it. A machine that can satisfy 90% of doctors. But even with a 90% satisfaction rate, there are still some scenes that cannot satisfy everyone. For example, the two-guard CT originally designed for short people. A tall person suddenly comes. After clamping the head and tail, the tall person's buttocks would sag down. The buttocks and their accessories are always unclear. What should we do? So people put up a bunch of tree branches, hoping to lift up its buttocks, so that the buttocks can return to where they belong. But when the butt turns up, the vertical card must fall quickly to avoid unexpected situations. For another, some examinations require CT to be done in one go. That requires that the instrument must hold the patient's foot. To complete the final scan, this requires both the device. Both put forward high demands. Both of them must be strong enough to complete it. To complete the examination, practicing pruning branches with a chainsaw after so much effort and solved so many problems. Have you ever thought that actually just give the patient a bed and a rotating cutting head, all the problems would be solved? Wouldn't they? No need for so many lifting brackets. And there's no need for so many running chucks. And there's no need for so many avoidance actions. All we need to do is let the patient lie quietly in bed. Let the system and cutting head change positions and take photos. Rumor has it that Jobs never did market research. Because he said that if Ford had done market research before, conducted market research, what Ford would have made would have been a faster horse. But a faster horse? Honestly, the four-way servo support of the pipe cutter, it doesn't really play a big role in heavy pipe cutting. Either it can't stick, or the operator will call the police, or it can't be fed. The guide tube can also provide some support. But for heavy pipes, especially in Xingtai, it seems a bit difficult. But when the pipe is relatively long, you have to use PTFE support to support the material, to prevent shaking. So the support is a chuck-type pipe cutting machine, is a necessary structure since it's useless. Why do we add so many moving supports? First, when thin-walled pipes rotate, the body will swing. Second, due to the gravity of the material, it will bend and deform. Third, because the material itself has deformation in the axis direction. But when we reverse it, when the pipe lies quietly on the machine tool, these problems above, can all these problems be solved? First, the pipe is still, there will be no swinging. Second, the pipe lies flat on the machine bed, will not be deformed by gravity. Third, the deformation of the pipe itself is fixed. It will not be deformed again due to rotation.
But how to load without PTFE support?
Can we just put the patient directly on the bed instead of clamping with 2 clamps? And then put tree branches under the patient's foot. This is nothing but increase a lot of additional machining costs. And the cost of the 4-way motor, there are densely packed drivers in the cabinet. It also increases the difficulty of control and the probability of failure. In addition, there is another problem with the chuck. The system defaults. In the processing, the pipe is a straight rigid body, and it is assumed that wherever it is welded, it will not break or deform in any way. But in reality, like this, or for example, suspended pipes will sag when changing hands, and the pipe head cannot be aligned with the chuck and smoothly caught. So whether it's a light or heavy pipe, only by actual cutting, you will know if the handover cutting can proceed smoothly. If it goes smoothly, everyone is happy. But for the first heavy pipe, if the above situation occurs, Super Zero will be sad. Do you know what the masters of heavy pipes fear most? Is it too much work? No, as long as the machine runs smoothly. He can handle it. Is it the heavy pipe? No, there is a crane. Is it the many parts for loading? It can unload the parts by itself when receiving. The most feared thing is that the V-joint should be connected. The parts that should be combined are forgotten. A section of pipe has been pulled off the V-belt. So all these helplessness is because next, reinstall the remaining pipes and select new paths. And select a new path and recoordinate. The most frustrating thing for the expert, or even annoyed, is the unexpected alarm in the first cutting anomaly. The most common situation is the pipe surface has protrusions or depressions. Servo alarms will occur during the Y-axis movement. It can be reset and continue after the alarm, or even can't find the brake, and the scrap material is scrapped. Machines with origin switches and incremental encoders. The safest way is to unload the tail material, zero each axis, and then install the scrap material and find the 0 point again. After all these operations, the operator will curse. At this time, it is very likely that the pipe needs to be kicked out of the holes of the chuck. Then remove it, clear the alarm, zero it again, and then put it back in place. This is a very tormenting process. Very tormenting. The mentality will make the operator very irritable. Some machines use absolute coding. Machines with servo mode can retract a little more after the alarm and then continue cutting, but there is an exception. When the Y-axis moves in the air and gets stuck, the claw and the bow slipped apart. At this time, even if the motor returns to the power-off position, the bow is not in its original position. What's more annoying is, this situation is very hidden. It can only be discovered after continuing the cutting, such as finding that the road cannot be combined, or the length of the part is abnormal. In short, when you find out, it's almost too late. There is almost no room for recovery.
Pay for the pipe. Processing 500, 2004 pipes.
So for safety, it's better to do a discharge zeroing, install power off, and continue cutting cycle. Cow Jizaya, curse it again.
Does the pipe cutting machine without a chuck have this problem?
Yes, but the probability is much lower. Firstly, the clamping position of the non-chuck pipe cutting machine. For multi-chuck pipe cutters, at least 2 sets of chucks hold the pipe. If any chuck is clamped into the chuck pit, it will cause an alarm. In addition, the more clamps during the process, the greater the friction the Y-axis motor needs to fight. Even the clamping force of the rear chuck needs to be increased. This will, in fact, brings a lot of unnecessary trouble. The tube cutting machine adopts a dual motor feeding shaft to drive heavy pipes. Therefore, similar faults may be much lower. There is another more troublesome case. Non-circular pipes has a twisted cross-section like a twist. At this time, the B-axis that drives the chuck to rotate also needs to bear additional load. For example, when the I-beam is twisted in section, after the 3 chucks are clamped, they start to consume, B1 says, determine the horizontal direction from my angle. But because the pipe has twisted, B2 disagrees with B1. B3 doesn't agree with B2's statement and disagrees with B1 even more. What should we do? Then they all follow their own opinions. So at the moment when the gripper is clamped, they all fell into a state of internal friction. The torque used to rotate the pipe is actually the remaining part of the force. In this case, the chuck, the gearbox, and motor's life will be greatly affected. Especially the chuck will hardly end well after working for a while. The pipes with poor quality are almost internal injuries. The clamping accuracy will almost inevitably. Abnormal noise and component damage are just a matter of time. For example, When processing short parts at the end, multi-chuck machines will use the instruction of microlink and tail part to ensure that the front and rear clamps can reach the final merged part. The length of the part. Therefore, the blanking program will also be triggered to trigger different PLC programs. But in fact, the width of the feeding plate of most cannot be well matched. The tail part, the distance between the smallest merged parts. Therefore, the cutting of the last part can only be done in this way, single card clamping, and then the part falls off and damaged chuck. We collectively call these problems the sleeve, the success rate of the first cutting, which is often overlooked by many buyers. It largely determine the production efficiency.
Some people say, isn't it the cutting speed and laser power? Determine the production efficiency.
The key is heavy pipe cutting. It's not true. Power and cutting speed determine production efficiency. Heavy pipe cutting actually takes a lot of time. It's spent on feeding and small-scale trial cutting. Experienced nesting players will have different layouts in mind during the complete chuck switching process, can make many preventive settings. But when the y-axis coordinates of the tube head to 0, the triggered chuck switching actions are different. This brings great uncertainty, which causes the problem we mentioned before, the problem of the first cutting failure. So whether the equipment is easy to use is the upper limit of the equipment's capacity. Don't consider the operator's dedication. The lower limit of productivity is the tool. If the equipment is easy to use, the operator, whether they work or not, will be higher than the production of the fully loaded equipment. After comparing with multi-chuck pipe cutting, we will compare it with the steel cutter, the tube cutting machine. The time spent switching the cutting surface is much less in the total processing time. Posture switching, empty movement, and section centering account for a large part, take up a large part of the total time. The proportion of your processing time is not high. This is also the steel cutting machine, the main reason for the low processing efficiency. Let's take the switching of left and right sections of I-beams to see the time difference between them. The cutting and moving process of the section steel cutter. In total 5 steps. Left up, right, down, and then left again. The process of the pipe cutting machine in total. 3 steps, up, rotation, down. We use the video without to compare the time difference between these two types. The empty moving speed of the x-axis of the steel cutter is hard to exceed 30 meters per minute. So the total time for completing 5 actions is much higher than the rotation time of the CNC. The rotation speed of the pipe cutter is about 20 to 30 rotations per minute. So as we can see, the overall time for face change of the CNC is much lower than the CNC. Does this have a big impact? It's significant, because in the process of steel, except for pipes with specific one-sided processing needs, do not need to change the face by the chuck, most of them require face movement to process different surfaces. So most of the empty movements require screen movement. Even if there is no need to change the face, the pipe group also needs picture movement actions. So the speed of the face changing action has a great impact on the overall processing time. In our previous video, the time difference of single face processing clearly reflects this gap. It's just like the difference in air movement, the time difference in speed. Yes, is high picture efficiency useful or not? Or is it worth spending a lot of money on it? To try this new thing, let me give you an example. People in tech held a contemptuous attitude towards high-speed machines. But when many people began to spend real money to choose high-speed machines, everyone began to rethink it. After all, those who watch it only need to use brain and emotion, can draw conclusions easily, but they spend real money to make investment decisions. So this incident makes me reconsider the word efficiency in the equipment purchase. Fast equipment and smooth use, it can definitely bring more potential benefits. In addition, the whole feeding of the section steel and the whole part blanking must be done manually. But the non-chuck pipe cutter can be completed through the feeding mechanism. Automatic feeding of whole pipes after cutting. After the parts fall off by themselves, the machine can execute the next part's processing.
After talking so much about the advantages, does it have no disadvantages?
Of course, yes. First, it's for small pipes. The corners are difficult to cut well during processing. Second, the total length of the equipment is longer. It's not easy to place in a limited space. Third, the parts must be all 0 during the process, because the overall feeding action needs to be done. So all parts must be 0. Until the moment of the final blanking, they are all broken. Of course, for heavy pipe processing, this is not a big problem. For small pipes with requirements for the cutting surface, need to be noticed. So the main application scope of the non-chuck pipe cutter are for cutting heavy pipes and steel sections. These two types of processing can greatly improve processing efficiency and reduce processing. The non-chuck pipe cutting machine actually there are many derivative models and different application scenarios. We look forward to seeing more improved models. So the conclusion is that in heavy pipe processing, multi-chuck pipe cutting machine is not the best. But currently, when choosing a processing machine for large pipe, there are few choices, except for large multi-chuck laser pipe cutting machines, is a steel cutter with a set of chucks, or entrust the manufacturer to develop special machines, such as oil screen pipes, the whole pipe processing and similar special industries. Obviously, the cost of the first and third options be kept low. The accuracy of the second option is average, and it's hard to design a matching feeding mechanism. So ultimately choose multi-chuck laser pipe cutting machine. But in fact, about 550 in the range of pipe processing equipment. The non-chuck pipe cutting and the price of multi-chuck pipe are almost equal. For example, a 550 diameter is determined by the weight of the pipe. Such a pipe cutting machine basically starts with 3 chucks. If you want to improve processing efficiency, it must be a 4-chuck one. The price of this kind of machine is almost the same as that of 5. When the diameter of the pipe increases further, the price advantage of pipe cutting machine will be reflected.
Feel free to reach out to Comic. We tailor the right equipment solution to your processing needs.